everybody. In this video we're going to be talking about circuit elements. So there will be voltage source, current source, and resistor. Later in the course we'll bring in inductors and capacitors. But then for voltage sources and current sources, a voltage source, it just looks like this. Like it has a plus and a minus, so you know which way is the higher voltage side. And then for a current source, it's just like this arrow to show which way the positive charge flow is going. And then notice that you can draw it like a circle or like a diamond. So circle means independent voltage source, whereas the diamond shape means dependent. So that means whatever, like that's 10 volts constantly, or like that's like 5 milliamps constantly. But once it's this diamond, it means here, like this is a voltage source, right? Because you see that plus and minus, but the voltage depends on the voltage somewhere else. And then this is just a coefficient, like a gain. So that means this voltage source depends on the voltage somewhere else. So it's a voltage dependent voltage source. This one, see here, this voltage source depends on the current somewhere else in the circuit. So it's a current dependent voltage source. Right? This is a current source that depends on the voltage somewhere else. So it's a voltage dependent current source. And then here, it's a current source that depends on the current somewhere else. So current dependent current source. Okay, so we'll dive into some examples of these later. For resistors, there is a relationship between voltage and current, and that is Ohm's law. This V equals IR or V equals negative IR, depending on how you pick your coordinates, basically, right? Which way you choose the direction for the voltage, which way you choose the direction for the current. Okay. So just like last time, right, if you see voltage, if you label voltage positive this way and current is positive this way, right, then that's positive. But if you choose, say, voltage is positive, drop this way, but the current is this way, see how that's backwards? So that's why there's this minus sign. Just like power, right, when we're going over power, see how voltage is positive from 1 to 2, current is positive from 1 to 2, that's why this is positive. And similarly, Ohm's law is like this. Here, voltage positive from 1 to 2, but current is positive from 2 to 1. So here, see how they're backwards? So that's why this is negative, and also Ohm's law would be negative. Here, voltage drop from 2 to 1, current is going from 1 to 2, so that's backwards, minus sign here. Ohm's law is negative. And then here, voltage drop from 2 to 1, and then the current is going from 2 to 1. So those are positive, so Ohm's law is similarly positive. Right, so it all depends on how you label your voltage and current. There's no right way or wrong way, just you choose and you're right. If we combine these, see how voltage is right there? So power is VI, but V is IR, right? So if you multiply it, that's I squared R. So that's another way to compute power. If you know the current and you know the resistance, I squared R. Or power is VI but I is V over R from Ohm's law. V over R. Multiply these together, V squared over R. So if you know the voltage and you know the resistance, V squared over R. But what about if you label it this way? So now look, power is negative V I. And then let's use Ohm's law. V is negative I R. But look, this negative and negative cancel each other. So it's I squared R. And then again, V power is negative V I. And then from Ohm's law, I is negative V over R. Negative V over R. Multiplies, see that minus and that minus? V squared over R. So notice the trend here. Basically, right, P is negative VI. V is negative IR. So this is positive I squared R. Negative V times I, but I is negative V over R. So this is V squared over R. Same story here, right? VI. VI. Oh, wrong one. Write the other one. I squared R. V squared over R. So it doesn't matter which way you label voltage and current. In terms of power, right? Look. The power absorbed by the resistor is always positive. Always absorb. Always. Right? That power for the resistor is always positive. It's just like when you're dragging a box on the floor. Like if I drag it toward the right, there's friction to the left. So the displacement is to the right, friction is to the left. The work by friction is negative. But if I drag the box to the left, the displacement is left, the friction is to the right, so then the work by friction is also negative. It doesn't matter which way you drag something on the floor, the work by friction is always negative. It's absorbing energy and then dissipating it as heat. So sometimes I catch myself, I say resistors absorb power from the circuit and then it dissipates that power as heat. So sometimes I say resistors dissipate power. By that I mean, right, they're getting rid of power through heat. Okay, so let's practice a little bit with Ohm's law. So right here, let's say we have current going this way. So we can label however we want, right? You can say, I'm going to make voltage like this. And then see how the current is going like this? So I'm going to choose current like this. So based on how I chose voltage and current, V is IR, right? So can you solve for the voltage here? Right? We know the current is 15 milliamps. We know the resistance. Right? So this is 15 milliamps. And that's 3 kilo ohms. Right? So just multiply these together and it would be positive. Not too bad, right? How much power? Power is, I already know the current and I already know the resistance. So do you want to use this or this or this? They're all the same, right? So since I already know current and resistance, just right here, right? 15 milliamps, 3 kilo ohms, and then we're done. Okay, let's try something that looks just a little bit different here. So now we have a voltage source. So you can label this however you want, right? So since I already have this here, why don't I just label it like this? So if that's 40, that's also 40. Then I'll label the current like this. So see how since voltage drop this way, current is this way, so that means V is IR. So would you be able to solve for the current? Right, so I is V over R. I know the voltage, I know the resistance, I can solve for current. How about power? So right, which of these three would you use? I mean, they're all correct. I already know voltage, I already know the resistance, so immediately I can just plug this in right here, right? That's it, and then I got this answer, right? Okay, thanks for listening to this. I'll see you on the next video.